you just do look once. This is the resistance, galvanometer resistance G, P, Q, this is R, this is it. Then what I'm seeing here is, I'll say that A and B, or select A, B, this is C, D, no? C and D are at same potential because the condition is satisfied. P by Q equal to R by S. So therefore, VC equal to VD. So then what you are going to do, you are going to replace like this, no? You are going to replace. So tell me, like, now what is the effective resistance seen by the cell? Is this circuit will be correct, or will you do like this? that you made a common. The circuit another, P and Q, what happened? The C and D are at same potential, no? You have to justify. You solve it, will you get same answer or different answer? You have to justify. PQ, there's a common point, CD. So calculate in this case, how much you'll get? PR by P plus R, QS by Q plus S. So effective resistance as seen by the cell. So let's calculate the expression for current, P plus Q, R plus S. So what is the expression for current in this case will be I is equal to the effective resistance 1 by R effective will agree. And when you calculate E, it will be this much. You calculate in this case. So PR by P plus R, that is in series with this one. So that the current here, what I'll get it will be totally different. You can check it now. The effective resistance will be PQ by P plus Q, PR are these two equal? I'm putting some R effective dash. Then what is I is equal to E by, but current should be same, no? One student did like this. This is the first method. Second student did like this. Tell me who is right. I think practically we are going to measure. So when we measure, then the one which, the assumption which matches practical, I think that will be the made final rule. So that finally open, that should be accepted. Okay, will it be same? I and I dash, will it be same? R effective in this case and this case will be definitely different, no? So tell me one is wrong, one is right. So this is right, this is correct, this is wrong. So what happened here now? What we did? So when current through galvanometer is 0, then we remove that galvanometer. We remove that galvanometer. Then C and D are at same potential. Again, you cannot make them rejoin. It's over. Once you remove a resistor, finish, leave it. But here, what happens if there no resistor directly connected? Then C and D are at same potential. What you should do? You should make them as common. I think these are the only two important things in entire this discussion. You solve any number of numericals, no? These are the two basic ideas. If a resistor directly connected across equipotential points, remove that resistor, finish, redraw the circuit. I'm not saying further anything. Second situation. If a resistor is not directly connected across equipotential, so what you should do? Make those 2 points common and redraw the circuit.
Sir,
Yeah.
in both the cases, I found out the equivalent resistance, and for the current to the galvanometer to be 0, I took the relation P by Q equal to R by S. I solved both, and for all the values of PQRS, I'm getting same value of resistance, equivalent resistance in both the cases.
You solve these two networks, I'm telling.
Yes, sir. I solved and I got same.
You solve this, it will be different. Just assume some values.
I took variables, sir. I took PQRS 4 variables and I solved. I got same in both the cases.
No, you check it. This is a very basic thing. So the effective resistance here, you see that, okay, now you do one thing. Let me, this will be I1 and I2, no? The current that will flow here. So what about the current that will pass through them now? So you mean to say that like if the C and D we made at same potential, no? So here what will happen? It'll be like this. So again, when you bring some ammeter and connect it here, no, the current through that ammeter again will be zero. But practically what happen if you join them by a wire, no? So definitely uh, we have discussed this one problem. Will there be any flow of current? Yes, it will be. I think here just like a practically if you connect one any ammeter, the current through this ammeter will be non-zero. Here I do get some current here. Then this will be how much? I1 minus I3. This will be how much? I2 plus I3. This is what happens. Otherwise, the books, they would have concluded this one. Then if you check the power dissipation, no? What power dissipation you should have here and what power dissipation you should have here are totally different. That's why the books open, they just made these two statements and left it. So you should not mess up things here. If really that condition were there, they would have mentioned. So when you connect one emitter, because you are saying that, no, I'll join them. So nothing but you are going to connect a wire. Then if you measure that current, so here, look at this circuit, no? I1 and here I1 minus I3. How come these two are same? You're just
If
analyzing
I3
with,
is 0.
you're joining a wire, but practically there'll be a flow of current, no? We have discussed this question. So totally I'll be giving you some different situation. I think so no book in the world till now has seen where it was done like this again. Because the performance of
Sir,
the
for
elements,
Wheatstone bridge, the current should be 0. Just now you discussed, no, sir.
here again what you're doing, you're connecting them by, see, you're joining them by means you're joining by a wire. So there'll be a flow of current practically. But we in live open, we never do, we just leave it here only. If you connect by a wire, no, again the power dissipation in the resistors will be different across QS, that one. On paper you are analyzing fine, but something really
Previous
totally
problem we
different.
got the same answer sheet.
Here I'm telling this one, here you look at the current I3 will be non-zero. Check it. I3 will be non-zero. So the now totally different situations will come. That's what I mean to say. The performance of these are two different circuits. Huh? Maybe you'll end up with same answer, but this will be wrong idea. From here, I should not say these two are same circuits. The power dissipations will be different across some elements. So definitely the 192 are not same. That's why you look at all the numericals. No, we never do this particular operation. What you are doing. So I'm strictly following the basic rules what you are given in book. You end up mathematically the same. Doesn't mean that the procedure what happen you can carry on wherever you want. Okay, so you have to be alert. So everything what happen has to be analyzed. This on paper may appear something very similar, but practical open things will be totally different here. So that's why you refer almost any book. No way the condition given like this. After removing the resistor, make them common and redraw the circuit again. So just we'll stop it here only. Okay. Shall I stop? Any doubt?